Okay, if we look at example 4, we're going to do what we've done before. We're going to take the permanganate and classify it as paired up with the manganese 2 plus. Okay, and we're going to take, now notice we've got C2O4 minus. It's got carbon and oxygen in it. So we're going to pair that up with the CO2. C2O4 2 minus going to CO2. Okay, so now let's actually start with the first one because we've seen this before. We've got a manganese ion and a manganese ion, and it's 1-to-1, so that's balanced in terms of atoms. We have 4 oxygens here, so we need 4 H2Os to give us those 4 oxygens on the product side. And we've created 8 hydrogens here, so we need to add 8 hydrogens here to balance the hydrogen. So all the atoms are now balanced. Let's actually consider our charges. So we've got a +8 here, and a -1 gives us +7 on the reactant side. On the product side, I have +2 and 0 gives me +2 on the product side. So I need to actually balance that by adding negative charges, which are the electrons. So I'm going to have -5 on this side, +8 -1 changes this to a +2. So my +2 and my +2s are balanced, and my -5s are going to be created by those 5 electrons. That means my permanganate ion, MnO4-, has gained electrons. And that means gaining electrons is reduction. So we know this is a reduction process. The next one is more interesting because the number of atoms are different. So notice we have 2 carbons on this side and only 1 carbon here. So we need to automatically double everything here. So the carbon atoms are balanced. And now notice that by doing so, we've actually gone from 4 oxygens here, and we now have 4 oxygens here. So our atoms are now balanced for oxygens. I don't need to add water and hydrogens. I just need to balance the charges. So if we look then, I have a -2 on this side and I have a 0 on this side. So how am I going to make them equal? By adding negative charges. I add a -2 over here. That adds up to -2. So that means that how am I going to add -2? Add 2 electrons. Okay, so we're adding 2 electrons. Okay, so that means that we have the C2O4 2- has changed into 2 CO2s, and in that process, 2 electrons are lost. So that means the C2O4, that oxalate ion, has lost electrons, and therefore the process is oxidation. So let's actually look at our numbers. 2 electrons have been lost, and 5 electrons have been gained. So we need a common factor between 2 and 5, which is 10. That means we're going to take this whole first equation and multiply everything by 2. And we're going to take this whole second equation and multiply everything by 5. And so then if we add these all up together, we're going to have 10 electrons plus 16 hydrogens plus 2 MnO4s plus 5 oxalates. All right, because I've taken the 5 here. Then I'm going to have 2 Mn2 plus, 8 H2Os, 10 CO2s, and 10 electrons. Right, so that means our 10 electrons can cancel, and we now have a balanced equation, right? And let's just highlight that. So our balanced equation is here. Let's just do that a bit bigger. So our balanced equation is here. Nothing else cancels on both sides. And let's just double check with our charges. So I have a +16, and this is a minus charge here. It's a permanganate. So -2, -10. So what does this all add up to? Positive 4. I have a positive 4 on the reactant side. 2 times plus 2 is plus 4, 0 and 0. So I have a plus 4 on the product side, and that's our check.